In this lesson, we're going to go over how to construct a box plot for a data set. So a box plot is another way of graphically displaying a data set. And it's a very nice and simple way to graphically display a set of data, and it's based on quartiles and the minimum and maximum values in the set of data. So to construct a box plot is pretty simple. You only have 5 statistics that you need to keep track of. You have to evaluate the minimum, which is easy. You just pick out the minimum. You pick out the maximum, which is also easy. And then you do have to calculate the first, second, and third quartiles from the data set. And you can do that by hand, or you can use Excel or a calculator to evaluate those. And then what you do is you graph them in this manner down here. So you put a little line like that right where your minimum value is. Notice this is your number line here, and you mark off where the minimum is. You mark off your first quartile, your second quartile or the median, and then your third quartile, and then you mark off where the maximum is. And then you just create this box in the middle right here. That's going to represent the all of the data from the first to the third quartile. And then you just draw these whiskers. These are called whiskers on the ends here, like this. And this is what we call a box plot for the data set. It's very nice representation for the data set because you see 25% of all your data is in this range right here. So in here is 25% of all your data right in here. You have another 25% in here. Do it like this, 25% going from Q1 to the median, another 25% here, and then in the whisker out here you have another 25% of your data. And so right in here between Q1 and Q3 you can see where 50% of your data lies. And so you can use this to see if your data is also skewed to one side. It can indicate whether it's might be normally distributed. For example, with this box plot right here, it looks like our data might be skewed a little bit to the right side. So in other words, our data set, if we were to do a histogram, it might look something like this, and then it would have a little tail extending off to the right because of the whisker extending off in this direction. So it's a very nice and simple way to represent a data set, and it gives you a nice understanding of the distribution. Now let's look at constructing one, and we're going to do that with the bare weight data. So right here we have our bare weight data set, and in column I you see we have all the weights. So let's construct a box and whisker plot for the bare weights. Now unfortunately Excel doesn't really have a very convenient box and whisker function. It won't do that for us graphically. We can easily calculate the minimum, maximum, and the quartiles, but then we have to draw it by hand or use some other software package. Excel doesn't have a nice box and whisker feature built into it. So let's sort this data, pick out the min, max, and then we'll do our quartiles. So remember to sort the data easily. We'll highlight those, and then remember what we can do is bring that down so you can see it. We would go over here to the sort and filter. We'll add in some filters, you see, and then we can sort everything just by the weights. So we'll sort from smallest to largest. There we go. Okay, so now we can see that our minimum value is 26. So let's just keep track of this here. So the minimum is 26. The maximum bare weight is 514 down here. We see that. So our max is 514. Now let's calculate our quartiles. Now we'll do these by hand, and I'll also show you how you can do them with Excel. So for Q1, remember, first of all, we need to calculate L25. And so that is going to be, let's see, how many bare weights do we have? Well, we should have 54 bare weights. Let's double check that. Yeah, we have 55 and then the header row, so we have 54 bare weights. So L25 is going to be 54 plus 1. Remember, we add 1 to the number of values that we have, so it's going to be 54 plus 1 times 25 over 100, or 0.25. And we get 13.75. So what that means is Q1 is going to be 75% of the way between the 13th and 14th score. So therefore Q1 is going to be, let's see, we have to go down here to X13. Now remember, we have a header row here that takes up one value. So the 13th data value is actually going to be where 14, and the 14th value is where 15 is. So we come over here, 80 and 86. Okay, so Q1 is going to be 80 plus, now the difference between 80 and 86 is 6 units, and so we have to go 75% of the way from 80 to 86. So in other words, we have to go 86 minus 80, which is 6 of course, and then times that by 0.75. So that'll be 75% of the way between 86 and 80. That's where Q1 is. Q1 is 75% of the way between these two numbers. And this is how we do it. We start with 80, and then we go 75% of the difference between them. And when we evaluate that, we get 84.5. Okay, that's Q1. Now for Q2, we have to calculate L50. So that's going to be 55, 54 plus 1, times 0.5. And that is 27.5. And so Q2 is going to be halfway between the 27th and 28th score. So Q2, let's see, we need to go down here and we need to find the 27th and 28th score. Let's see, that's going to be right here. That's actually going to be 28 and 29 because we have the header row. And oh, both of them are 150. So Q2 is actually going to be halfway between 150 and 150. Well, that means Q2 is just going to be 150, halfway between those two numbers. So Q2 is 150. And then for Q3, we need to calculate L75. Q3 is the 75th percentile, and so it's going to be 55 times 0.75. And that is 41.25. Okay, so Q3 is 25% of the way between the 41st and 42nd score. Alright, so we need to go find those scores. Let's see, so we go down. Alright, here they are. Let's see, 41 and 42 are actually going to be 42 and 43 here. And so going over, that's going to be, so we have to go 25% of the way between 236 and 262. So Q3 is going to be 236 plus, and we have to look at the difference between 262 minus 236 times 0.25. and we get 242.5. Okay, so here are all the numbers that we need to use to create our box and whisker plot. Our min, our max, and then our quartiles, Q1, Q2, and Q3. Alright, so let's do that. Let's keep track of those numbers. Let's see, I'll just need to create a little blank space here. Okay, so we'll just put our box plot over here. So we just have to create an axis right here. So that's going to be our x-axis. And then we just need to mark off, let's see, we'll start with 0, just roughly 100, 200, 300, 400, and 500. 0 out to 500. Okay, now we mark off our minimum. Let's see, our minimum is 26. That would be about right here. And it's nice to put the number 26 right above that. Our Q1 is 84.5. Let's see if this is 100. 84.5, just very roughly, since we're doing this by hand, that would be about right there. So it would be 84.5. Q2 is 150. Let's see, this is 100, 200, so Q2 would be about right here. That's 150. Q3 is 242. Let's see, so that's going to be, this is 200 and 300, so 242 will be about right here, let's say. 242.5. And then our maximum is 514, so that's all the way out here. And then we create our box, and then our whiskers. And there is our box plot. Oh, and let's put 514 right here. And there is our box and whisker plot for the bear weight data set. And you can see this is a very nice representation. You can immediately read off about 50% of your bears, the middle 50%, had weights between 84.5 and 242.5. 25% of your bears had weights less than 84.5. 25% had weights more than 242.5. And you can see that your data set is skewed to the right side. So as we saw when we did the histogram for the bear weight data set, you know, remember our histogram looks sort of like this with a tail extending out to the right. So that is indicated by the box and whisker plot. One final thing about box and whisker plots, sometimes if you have outliers, data values that are very, very large in comparison to the rest of the data set, sometimes you might see box and whisker plots drawn where you have a little asterisk representing an outlier. You know, maybe you had a bear that weighed 650 pounds or something. A highly unusual score would be indicated with a little asterisk like that. Or down here, you might do the same. That's sort of up to the user to determine what might be an outlier. An outlier could even be an error in a data set. You know, maybe a transposition of two numbers in error, but you might not be certain that that's what actually happened, but you might think, you might believe that there's actually an error in one of these numbers, so you might include it as an outlier. Alright, now before we leave this video, let me show you how to calculate these quartiles using Excel. So let's go back up to that bear weight values. So I'm going to erase my box plot here. So let's do the 84.5 first. Now remember, we'll put that right in this cell here. Let Let me blow that up just a little bit. Now, can't see it then. Okay, so let's find the 84.5. So we're going to use the percentile feature, and remember Q1 is the 25th percentile, so we're going to go equals percentile, and remember the one we want is the exclusive percentile .exc, so we highlight that one. Let me move this over a little bit here. Okay, so there's the function that we're, oops, wait, no, we don't want percentile rank, sorry, hold on a second. We want just percentile exc. There we go. And now we want to highlight all of our weights here. Hit enter. And just highlight the weights. You didn't have to hit enter, sorry. And then comma 0.25. Oops, comma 0.25. Close off your parenthesis, hit enter, and there you go, 84.5. Let's do Q2. So we'll just actually copy this down here. Oops, okay, can't do that, sorry, it changed my array. We'll have to redo it. So equals percentile exclusive, highlight our array. Now we could just highlight it like that. Excel will be smart enough to know that the weight is a header value, comma 0.5, and that'll give us the median, or Q2. And let's see what we get. We get 150. Q3 percentile .exc. Oops. And our weight column, comma 0.75. Close the parenthesis off, and then hit enter. And there we go, 242.5, and those are all the numbers that we found exactly. Okay, you just have to remember to use that percentile. The one we're using is the percentile.exc. That's the one that we want to use. Don't use the .inc. That'll give you different numbers. Alright, and so that concludes this video on constructing box plots.